Good morning, dear students. Sorry for not being able to do any recording. Any earlier. So This is a quick recording for a variety of requests made by the students. I hope that you find them useful before you do your examination. I think you're gonna do your examination by afternoon. So I hope that you find these last videos beneficial regarding how you perform in the exam. And with my best wishes for your exams, guys. And this problem is talking about how you can describe the inequalities of a shaded region. What you see in front of you here is this is a shaded region. It's an area, okay? We call it shaded region. Shaded region. And the request in this example is to remove the tools here. The request in this problem is to write down three inequalities that define this shaded area. So from our understanding for inequalities is a description of possible values for anything. So with the logical operators. So when I say x bigger than or equal 3, when I say y is less than bigger than or equal 0, and less than or equal 3, these logical operators, we define them as inequalities. You're trying to put all the possible values that can describe the shaded region in front of you. The thing that I want you to understand, there's a few things that you need to keep in mind when you're dealing with the inequality problems and when you are dealing with the inequality graphically, not algebraically. First of all, there's few tips that you need to understand. uh, if straight lines are not dotted, it means that you're dealing with less than or equal or bigger than or equal as an operator to describe your inequality. If it's not dotted, if it was dotted, which is not the case here, as you can see in front of you. Look at the lines. The lines, they are connected. They're not dotted, if you got what I'm trying to say here. Since you have connected and continuous lines, they're not dashed. They're not dashed because there's a big difference between them. If you see these lines as dashed, you're not gonna deal with less than or equal or bigger than or equal. You're gonna just use these operators. You're gonna use the less than or equal than. You can use less than or equal than. What is the meaning of that? It means that if you have a dotted line, it means that any point on these lines are not part of solution. You got the idea? So that's it when you're dealing with inequalities. If you have a dotted line, you're gonna use this to describe the inequalities. And since we have a straight lines, we have continuous lines, we're just gonna use bigger than or equal or less than, bigger than or equal. So now let's go to the geometry that you see in front of you, or we call it the shape in front of you. What you see in front of you, it's a shaded region that is surrounded by three lines. And one of the equations of the straight line, one of the straight lines equations was given for you, which is making your job a little bit easier. The other thing now you need to do is to figure out the equation of this straight line and the equation of this straight line. And graphically, when you see this one, this is, first of all, I'm going to start with the easy one. I'm talking about this one here. This one is a straight line. It's a vertical line that is crossing the x-axis at which point? It's crossing the x-axis at this point here. This point is actually -1 on the x-axis. Since it's equal to -1, it means that the equation of this line, as we learned, it's a vertical line, is gonna be referred to as x equal -1. This is the equation of this straight line. Now I'm just trying to give I'm gonna show you how you extract these equations, because these equations is gonna describe the inequalities, the three inequalities that you need. So basically you use the straight lines algebraic description to create inequalities. Now let's talk about this line that you see here, this line here that is crossing the 0 point in a certain way. As you can see, this line it's always equal. I mean, when you have y or x as 2, you have y as 2. When you have x as 4, y as 4. So from this description, this line looks like a direct proportion graph that is referred to as y equal x. Okay, this is the other equation that we figured out. So now I'm gonna create some space here after explaining the theory of using these straight lines. What is the difference between the dotted and dashed? Now I'm gonna write the three equations as they are: x equal -1, and the other equation is y equal x, and the other equation is equal to what is x plus 2y equal to 8. Now to the part of creating inequalities that is satisfying the shaded region. There's another important note now, how you can use these equations to satisfy the region. The idea is to pick a random point exists in the region. What is the meaning of that? It means that, for example, this point here, it's actually what? It's point 1 and point 2, right? I'm gonna use it to explain everything. So this point here, 1 and 2, it's a point that actually exists in the region. So we're gonna test it. We're gonna test this point with every equation. So the first equation is x equal -1, right? So when I try to look to the point 1 and 2 that I'm talking about, this point, we're gonna use it all the time in these three cases of three lines. I have a value of x equal to 1, right? So 1 is gonna be equal to -1. Now the idea that 1 is not equal to -1, I know that y is bigger than -1, and I know that I can use one of these two operators from our discussion. If you remember our discussion about that these are continued lines, so I can use one of these two to describe the inequality. So since I know that 1 is bigger than -1, so the first inequality is gonna be, so I can describe 1 as bigger than or equal -1. And since I'm dealing with this, it means that I can translate the equation or the straight line into the first inequality. The first inequality is gonna be x bigger than or equal -1. This is the first inequality, guys. You got the idea. This is how you create the inequality. It comes from the equation after you apply a point, a testing point that exists in the region. Now let's go to the other one, which is the straight line of y equal to, this is the first inequality. Now the other line that we have is y equal x, right? Y equal x. I know that I can write it in this form. It's going to be equal to y minus x equals 0, right? Now let's see what we can do with the, remember we have a point to test, right? It's 1 and 2. I can test this point here. I have 2 as a value of, the value of y is going to be 2 minus the value of x, which is 1, equals 0. And I notice that I have 1 equals 0. Now I understand that y is not equal to 0. and I have two possibilities to deal with. I can use the operator of less than or bigger than, or this one. It's up to you. So I know that 1 is bigger than 0, so I'm going to use this one. So 1 is going to be bigger than or equal 0, and from this I know that the second inequality is going to be what? Is going to be y minus x bigger than or equal 0. This is your second inequality. Clear so far? This is the second inequality that is describing the shaded region. Now let's go to the last equation, which is the one that was provided by the question. X plus 2, which is x plus 2y equal 8. Now let's describe our dear point 1 and 2. 1 and 2, this is the point that we keep testing. By the way, you can pick any other point as long as this point exists in the region. Pay attention to this fact. You cannot pick any random point. You can pick a point that exists in the region. Why is that? Because you need to make sure that this inequality satisfying the region. Okay, this inequality satisfying the region by solving, by picking a point that can solve these inequalities. So now I'm gonna test this equation as an equality. X is equal to 1, so 1 plus 2 multiplied in 1, which is 2, equal to 8. Now let's see what we got. 1 plus 4 equal to 8. It means that 5 is equal to 8. And as I said, you can use one of two things, because we have a continued line, so you can have bigger than or equal or less than or equal. And since 5 is less than 8, it means that 5 is gonna be less than or equal 8. It means that the third inequality is gonna be equal to what? You're gonna bring your equation here. So it means that x plus 2y is actually less than or equal 8. And this is your third inequality. Okay, this is the solution of this question. So this is your first inequality. So the first, I'm gonna write them down here. Okay, so your first inequality is gonna be x bigger than or equal minus 1, and the second one is gonna be y minus x bigger than or equal 0, and the third inequality that is satisfying your region is gonna be x plus 2y less than or equal 8. I hope that this video was explaining everything clearly. See you in the next video, inshallah.